Hello, I'm Thibaut Jacobs, Sales Application Engineer for Materialise, and I'm here to talk to you about the Materialise Chromatic software and how you can use it to enhance your designs for additive manufacturing. First, a word of introduction about Materialise as a company. So Materialise was founded in 1990 and has been active for nearly 30 years in the field of additive manufacturing. Materialise is divided in 3 departments. So we have the software department, where I'm active, where we develop and commercialize our software suites for additive manufacturing. Then we have the manufacturing department, where we print and produce parts for other companies. And we have the medical department, where we also produce medical software for additive manufacturing, and we produce medical implants that are customized for every patient. We also have surgical guides. So those are the 3 divisions. Here we have the Materialise software suite. So we'll focus today more on Materialise Chromatic, which is the design optimization software for additive manufacturing. Then we have Materialise Magics, which is the build preparation software, which allows you to prepare your platform and in order to print them. And we have also the Materialise build processor, which allows you to have a communication between Magics, so the build preparation software, and your machine. So the build processor will also do the slicing of your part and communicate with the machine, and you can also adjust the parameters of the machine. And also, Chromatic can interface with the build processor. So as we will see in the features of Chromatic, you can generate texture or lattice structures. And this link with the build processor enables you to make sure that you can print those kind of features of your designs by having a slice-based technology. I'll talk a little bit more about this in the next few moments. So why is design for additive manufacturing different? So traditionally, the design for traditional manufacturing is based more on the machining operations, which determine which kind of features you can have for your parts. So if you look here, for example, the part on the top, the holes are round. Why? Because it's easier to manufacture those holes with drills. While with additive manufacturing, complexity comes at no extra cost, and so it gives you a much more larger freedom of design. So why use Chromatic? Chromatic is not design software from scratch. It allows you to add some extra features that really take advantage of the added value of additive manufacturing. And we will see those features in a moment. So those features are the possibility to easily add textures to your parts and also lattice structures. So what are the key benefits of the Chromatic software? It has been conceived from the start for additive manufacturing. So we are always working in the Chromatic software with a representation of the geometry that is compatible with 3D printing, with additive manufacturing. We have a lot of interfaces with the major CAD and FEA softwares. So you can easily import your CAD designs in Chromatic to work on them and add those extra features. And you can also export your designs from Chromatic to the FEA software to even to check that your design corresponds to the specifications. And also, so as I mentioned earlier, we have this integration into the Materialise software suite. So also with the build processor, this enables to process complex designs with slice-based technology. The difference between Chromatic and AutoCAD package. So as I said, in Chromatic, we are always working in a representation of the geometry that is compatible with 3D printing. So we are always working with triangles. So the representation of the geometry internally in Chromatic is triangles, as you may already know. So STL files, which are necessary to print the parts. While in the CAD software, the representation of the geometry is a parametric representation, so you need to have a conversion first to STL in order to print the CAD geometry. So this conversion to STL means that you might require fixing of your STL representation before printing. So while in Chromatic, you already know that you can print it, and also in Chromatic, you have fixing tools to make sure that you can print your design. As you will see, so with the texture and the Lattice module, you are able to easily add those features that take the most advantage of additive manufacturing capabilities in Chromatic, while in CAD software, it's usually more tedious to add those kind of features. As I mentioned, Chromatic is really designed for additive manufacturing. So as I said, Materialise is active for nearly 30 years in the additive manufacturing industry. And so all our software are really always designed with additive manufacturing in mind, while for CAD software, it's usually oriented more toward traditional manufacturing. So the texturing module allows you to easily apply textures to your 3D designs. So why would you apply those textures? Here we have some ideas of applications. So first application would be for acoustic purposes. So this would allow you to improve the acoustic dampening on flat surfaces. Here I have a video. So as you can see here, if you add this texture on the surface, it will, I would say, diffract the acoustic wave and improve then the acoustic properties of this surface. Other application would be to increase the surface roughness. So here we have an application where it's a brake pedal, and so to have a better grip. So it could be the same for a handle for a golf club, for example, or a handlebar for a bike. It can also be just for aesthetic benefits. So here we have an application example with Samsonite for a suitcase. And there are also other possible applications. Here, for example, we could create those reflection elements for this headlight for an automotive application using the texturing module. So how does it work, the texturing module? It works by applying a grayscale image on the surface of your parts. So you can choose which surface you want to apply the texture. You choose the grayscale image, so it can be any image. As you can see, there's a pattern. So you should make sure that your image patterns in a seamless way. And then once you have applied this grayscale image on your surface, you can specify an offset value for the white color and the black color. And so the gray color in between will be interpolated between those two values. And so you can generate the texture in 3D on your surface. So here we have some examples of grayscale image and the corresponding results in the 3D texture. So this gives you an idea of the possibilities. But as I said, you can use any grayscale image that you want, as long as you have seamless patterning and you have also a good definition of the black and white. So you can have gray colors, but if you have too much gray, your texture will not be well defined. So here we have an application example. So this is for the creation of a mold for the shoe industry. So traditionally, this could take a lot of time with traditional manufacturing techniques. And here with additive manufacturing, we are able to quickly generate this kind of parts. So this is the master mold. And after that, you can launch the series production of this kind of part. And here you can see that using the Chromatic software, we were able to easily apply all the textures on the entirety of the part. So here we loaded the model from the CAD software, and in Chromatic, the representation of the surfaces that come from the CAD software is maintained, so you can easily select the surfaces that come from your CAD model, and then use those surfaces to apply the textures. So here you see the representation of the texture as they are applied to the surfaces in the black and white, and as we already saw, the final results of the printed part. The next module is the Lattice module. So the Lattice module enables you to make your parts lightweight while maintaining good mechanical properties. So here we see an application, again for pedal for an automotive application. And here this kind of lattice structures, of course, additive manufacturing is the only way to manufacture this kind of parts. It would be impossible with traditional manufacturing techniques. So we will see also this example. So by varying the thickness of the beams in the lattice structure, this enables us to change the macro characteristics of the lattice structure and kind of adjusting it to the application. So also by using a lattice structure, it's will use less material and thus lower cost, and also make it print faster. And also, so this is more for laser machine printing. By having less material and less cross-section, we will have less heat accumulation and so less risk of deformation while printing. So the different kind of lattice that are available in Chromatic. So we have the unit cell lattice, where you specify the volume that you want to fill with the lattice structure. You specify the unit cell that you want to use. So we have a library of unit cells that are available in Chromatic, and you are also free to create your own. It's quite easy to do in the software, and so you have a lot of freedom in that regard. So here you see how it would look like. So the volume, the unit cell, and the volume which has been replaced by the lattice structure. Another type of lattice that is available is the conformal lattice. So there the idea is that you really follow the surface. So again, you specify unit cell, and this unit cell will be applied around the surface. So here it's a closed surface, but also if you have an open surface, and really follow and be conformal with the surface. Here an example of application of the lattice structure. So we have an aerospace bracket in titanium. So of course, for aerospace, the lighter the parts are, the better to reduce fuel costs. So here we have the initial design space, so about 57,000 cubic millimeter. And within this design space, a topology optimization is applied to get to an initial design. So the topology optimization cannot be done in a Chromatic software, so for that you need another software. But then we can start from this topologically optimized parts and apply lattice structures to make the part even lighter, and also in some areas to avoid to put supports for printing. So that's the first step, is to generate the lattice structure, and then by changing the thickness of the beams of the lattice structure using FE analysis, we are able to reduce even further the weight of the parts to get to a final weight that is 37% of the initial design space. So how does it work in the software? So you specify the volumes that you want to replace with the lattice structures. So in this case, those are the volumes in green here in the parts, and in blue on the bottom, you see the unit cell that will be used to generate the lattice structure. And so using these unit cells and those volumes, this would be the resulting lattice structures. So you are free to change also the size of the unit cells as it will be in the lattice structure. And now that the lattice structure has been defined, the next step would be to apply the thickness to the beams. So this can be done in various ways. You can have a uniform thickness. You can specify a certain porosity that you want to attain, and the thickness will be varied accordingly by the software. You can also do FEA analysis and change the thickness of the beams based on the results of this analysis. Or you can also, as we will see in the next application example, use some image-based thickness for the lattice. So here again, it's a black and white image, and based on the black and the white areas of the image, you can change the thickness of the lattice structures. So in this case, we use FE analysis to change the thickness of the beams. So we exported the lattice structure to FEA software, made the simulation in the FEA software, and then we imported the results. And so based on the results, we changed the thickness of the beams. Here we have another application example. So those are customized and optimized insoles. So it's really customized for each individual customer. So the idea is that those customers work and run on this pressure pad that you can see. And this gives us a pressure map, so for working and running. And so we can combine those pressure maps and use them to, again, modify the thickness of the beams in the lattice structure, and have insoles that are really custom-made for each individual. So this concludes the presentation of the Chromatic software. What are the next steps? So first, based on this presentation, and also you can look more information on our website, decide if you want to use Chromatic for your projects, for your design. So then you can install Chromatic and learn it with the tutorials. So there's an integrated tutorial in the software in PDF format, and there are also some videos available on websites that should allow you to get started. And there will also be a half-a-day coaching session at Materialise. So this is scheduled the 5th of March, but will be confirmed soon.